Hi everyone, I hope everyone are doing well. In this video, we will try to understand how to draw the medians of isosceles triangle as well as a right angle triangle, and from the medians how to identify the centroid. Let me draw first the isosceles triangle with two sides are of equal length, which is 6 centimeters. So in isosceles triangle, we know that the two sides are of equal length and the third one is a different length. Okay, so I am drawing this. Let me show all the sides. So this is the isosceles triangle with sides AB, BC and CA. All these sides means, if you observe, the sides AB are 6 centimeter, 6 centimeter and 7.4 centimeter. How to draw the medians? We need to identify the midpoints of all the three sides, and we need to draw the lines from each and every opposite vertex, from A to BC, from B to AC, and from C to AB. We need to draw medians. Let me draw the medians with the help of a ruler. So these are the medians which I have drawn from all the vertices of uh, isosceles triangle. So the median which is drawn from the vertex A, I am assuming it as MA, and the median which is drawn from the vertex B is assumed as MB. Similarly, there is the third median which is drawn from the vertex C. I am assuming it as MC. Now, we know that the meeting point of all these three medians is called as a centroid. I am representing this with G, the point G. Okay. Now, we need to check that whether this centroid is dividing each and every median into 2 is to 1 ratio or not. Let me see the median BA. Okay. So, here if you observe, it is dividing, the centroid is dividing the median BC into the ratio of 4 is to 2. 4 is to 2 is nothing but 2 is to 1. Similarly, let me show the second median and its sides. Now, if you observe the median which is drawn from the vertex C, so one of its length is 2 and the another part length is 4. So which indicates that the centroid is dividing the median in the ratio of 2 is to 1. So this is 2 and this is 4, 4 units, because from 2 to 6 units the distance is 4 units or 4 centimeters. Now what about MA, the median which is drawn from A? Let me show that. With the help of ruler we can measure the lengths. So the distance from the vertex A to the centroid, here if you observe, it can be seen as 3.1, right? So let me put it properly. So the distance from the vertex A to the median G is almost 3.1, and let me write it. And the distance from the centroid to the side BC, the distance from the centroid to the side BC is almost 1.55 or 1.6. Here 1.6 is almost half of 3.1. Again we are getting the ratio in 2 is to 1. Okay, so that we can understand that the centroid here is dividing all the medians into 2 is to 1 ratio. We have checked this with the isosceles triangle where the two sides of triangle are of equal length. Here you can observe in this triangle the sides are of equal length, which is 6 centimeter and 6 centimeter, and another side length is 7.4 centimeters. This is about the isosceles triangle. So what we can understand from this, centroid of any triangle divides the medians Let me draw it. Let me write it. Centroid divides the medians into 2:1 ratio. We can do it ourselves and understand this fact. Okay. Now let me show with right angle triangle. Means we need to check whether it is same for the right angle triangle or not. So this is the right angle triangle with the sides AB, BC and CA. AB and BC are called as legs of this right angle triangle, where AC is the hypotenuse. Now if you observe, in a right angle triangle, the Pythagoras theorem will apply, which indicates that hypotenuse square is equal to the sum of the squares of the two legs. Means here 10 square, so I missed here, 10 square must be equal to 6 square plus 8 square. And how to draw the medians? I have taken all the midpoints of the three sides AB, BC and CA from each median to its opposite vertex. If you, sorry, from each midpoint to its opposite vertex, if you draw a line, it is called as a median. Now I have drawn all the three medians of this right angle triangle. Let me give the name for each and every median. So this median is drawn from the vertex A. So I am assuming this as MA. And another median is drawn from the vertex B. I am assuming it as MB. The third median is drawn from the vertex C. It is assumed as MC. Okay, these are the three medians, and the concurrency or the meeting point of all these three medians is called as a centroid. It is represented by the letter G as in previous case. Now I have measured the side lengths of each and every part. Now if you observe the median MB, it is the centroid is dividing it into 3.2 is to 1.6, which is a 2 is to 1, and the median MA is divided into two parts, and it is 4.8 is to 2.4, and again it is 2 is to 1 ratio. Similarly, the median which is drawn from the vertex C is having the parts as 2.85 and 5.7. So 5.7 is to 2.85 is again 2 is to 1. So this centroid, which is the meeting point of all the medians, is dividing all the three medians into 2 is to 1 ratio, whatever may be the triangle. Previously, we have observed this with isosceles triangle. Now we have done the same experiment with right angle triangle. So whatever may be the triangle, the centroid always divides the medians into 2 is to 1 ratio. Thank you very much for your patience.